Hi everyone, we have made it to our second to last foldable. You should have two pieces of paper, and I will have you pause this video so that you can copy down all the different sections of your foldable, and then we will begin our notes. And here's example 1. It says how many different lunches can be made with 2 bread choices, 4 meat choices, 3 cheese choices, and 6 chip choices. I'm going to give you a second. You can pause this video and try and figure it out, and then we will show the answer. Alright, to find this out, you're going to take 2 times 4 meat choices times the 3 cheese choices times the 6 chip choices, and when you multiply those all out, you should come up with 144 different lunches. Example 2 uses the 2 different Ohio state license plates. The format for each is shown by the examples that I have here. Which license plate, the first one or the second one, do you think offers more possibilities? How many more? Can you figure it out? Please pause the video. If you were stuck, this might help you. The first license plate has 7 different places for letters and numbers. The first 3 are occupied by letters, so there are 26 letters, 26 letters, 26 letters, because in this example we could use 3 A's. The next 4 are followed by numbers, and 0 through 9 we have 10 numbers, so 10, 10, 10, 10. The second one has 2 sets of letters, so 26, 26, then 2 numbers, 10, 10, and then another 26 times 26. So if you were stuck, you can try and figure this out now, and I will show the answers in just a second. Alright, here are your answers. With the first one, there is 175,760,000. With the second one, there is only 45,697,600. So the first license plate, even though it has fewer letters, it has more slots, and it gives you nearly 4 times as many license plates. Let's go to the next example. Alright, example 3. How many 7-letter passwords can be made without repeating a letter? Use the space example that I did before and figure out how many letters to start with, and then fill in, after you've used a letter, what the rest of them would be. I'll give you a second for that. Alright, when you take and write out your 7 spots, you start out with 26 letters, you use one of them. You have 25 remaining, 24, 23, 22, 21, and down to 20. When you multiply those all together, you get an answer of 3,315,312,000. So there are a lot of 7-digit passwords without repeating a letter. You would have even more if you could repeat a letter. The next thing that we need to talk about are permutations. Permutations are series of numbers in which, or people, different arrangements where the order matters. In a permutation, you cannot reuse things, and a lot of times it uses the keyword of arrangements. How many different ways can people finish a race? How many different arrangements of videos can you make? So if it says the word arrangements, you are talking about permutations. What I have here is what they used to provide with the OGT on the reference sheet. So when you took the OGT, you might see that this is familiar. This is one notation for a permutation that some textbooks use. This is the notation that the calculator uses, and this is the formula, if our calculators didn't do it for us, that we would have to use. But both of the red calculator and the graphing calculators have this permutation feature, and I'm going to show you how to use that. So this is just mainly for your reference. These exclamation points are factorials, and we will be talking about those in just a second. Alright, example 4. There are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? Well, this is a permutation because we have to have order. If you win a gold medal, that's better than winning a bronze. So the order is going to matter. The way we write P for permutation, there are 10 people total, and we want to make an arrangement of 3. So we have 10 people we are choosing, or we are picking for P3. In the calculator, you are going to have to put in the 10 first. Then you are going to get the option NPR, and then you are going to finally put in 3. So let me show you how this works. Alright, I can only show the graphing calculator on the screen. So what we do is we first enter 10, then we go to Math, and if you go all the way over, PRB stands for probability. Your second choice is NPR, so we're going to choose option 2, and then we need to put in the 3. Press enter, and it gives us our answer of 720. So this is simply an easy way to do it. It has all of the formulas for it. Go ahead and try the next one. Alright, hopefully you were able to come up with 6,840 in your calculator. Again, you press 20 first, then you go into Math over to Probability, option 2, and then you choose the 3. And now we will go to our next example. Sometimes you need permutations or arrangements of letters that repeat themselves. Some words, if you want to rearrange them and switch around the letters, and you have 2 L's and you switch them, it's not going to create a new word. So you're going to use each letter once, but some of the letters are going to repeat. Here's the best way I could come up with writing the formula. At the top, you're going to take the total number of letters that you have. So if your word has 10 letters total, you're going to put 10 factorial. Then at the bottom, each letter that repeats, you're going to write how many times it repeats. So if there are 2 A's, you're going to write 2 factorial. If there are 3 L's, you're going to also write 3 factorial. And if there are 2 O's, then you're going to put 2 factorial again. When you put this into the calculator, I'll show you how to get the exclamation point, but you must put the bottom in parentheses or it will not give you the correct answer. So let's go to an example. Alright, how many different ways can you arrange the letters of Mississippi? Well, if you count up the letters, you have 11 letters total. So you put 11 factorial. On the bottom, we have 4 I's, so 4 factorial. We have 4 S's, 4 factorial. And we have 2 P's, 2 factorial. So when I put this in my calculator, I have to put the bottom in parentheses. And before we go on, I want to explain what factorial means. If you have, let's use a smaller example, 5 factorial. What your calculator is going to do is it's going to start with 5 and multiply that by 4, 3, 2, 1, all the way down, and once it gets to 1, it's going to stop. If you have 7 factorial, we'll take 7, 6, 5, 4, 3, 2, 1, and multiply those together. So the calculator will figure this out. Let's just put it in and try. So I go and I hit 11. Factorial, which is also under Math, all the way over to Probability, and the factorial is option number 4. Divided by, and this is where I have to put in my parentheses, 4 factorial times 4 factorial times 2 factorial. Close my parentheses, and I come up with 34,650. So that would be how many different ways I can arrange those letters. They're not going to all make a word, but it would be a different order of the letters. Now we have the same thing with combinations. The difference between permutations and combinations is the order does not matter in a combination. You still cannot repeat things, so when you're thinking about this, do not think about locker combinations. Locker combinations can be 10, 5, 10. So a combination is not a locker combination. The order doesn't matter. So 5, 6, 7 is going to be the same as 7, 5, 6. They're the same grouping of those three things. This is, again, what would be on the OGT form. First one is a notation, the second one goes with your calculator, and the third one is a formula that we don't have to know because the calculator will do it for us. Alright, example 7. A group of 7 students needs to choose 2 students to present their findings. How many ways can they choose the 2 students? So this is a grouping. The order doesn't matter. The same 2 students are going to present. It doesn't matter who presents first. So we have a combination of 7 students that we are choosing 2 from. So the calculator notation, again, you have to type in the 7, then the NCR 2. So this is found at the same menu on your calculator. Alright, so you put in 7, you get the combination menu, you hit 2, and then your calculator gives you an answer of 21. Try the final one, and I will show the answer in just a second. So hopefully when you put that in your calculator, you came up with 1,140. This is the final example, so now your assignment is on the sideboard, and I will be back tomorrow if you have any questions. See ya!